Hey curious people, I'm here again today to explain polar and nonpolar covalent bonds. As you can see, I was going back and forth on whether I wanted to talk about bears or bonds, and ultimately I ended up with bonds. I hope y'all are having great days. You would not believe the day I had. It's actually insane. But yeah, anyways, let's let's begin this. So, polar bears. I'm kidding. We're not talking about bears, even though I love Ice Bear from We Bear Bears. I had a pen. I don't know where the pen went. Anyways, polar covalent bonds. What are those? What is this? Okay, slow down. Stop sign. That's what that is. Don't get ahead of me. Don't you're thinking too far ahead right now. Let's back it up and let's talk about covalent bonds first, because yeah, you probably should know what that is before you get into a subset of covalent bonding. So yeah, okay, so what are covalent bonds? Okay, well, to understand this, you need to know a teeny bit of rules. I'm sorry, I know we hate rules, I hate rules, you hate rules, except for when they're keeping us from robbing stores and stuff. Then the rules are good. So let's just go over the three commandments of bonding real quick. That's Moses in the back. I'm sorry, I can't draw. Anyways, I just recently learned these rules from Khan Academy because I was a little confused on covalent bonding too, and I was like, okay, I'm probably missing something. And then I just learned these rules, and I was like, okay, if Khan Academy said it, it must be true. So I'm gonna tell you guys too. So when you have two metals, the bond is likely metallic. I have no idea what a metallic bond is. I just learned about it. Hopefully I can learn more about it in the future. You know, we're all learning together. So yeah, I have nothing to say on that right now. Two nonmetals form, oh wait, but maybe one of you know, because based off of the previous comments I've gotten, y'all are like really smart. And yeah, this one person started talking to me about a rule. I forgot what the rule was. It started with a C, and I was like, what? I never heard of this before. So like, y'all are really smart. Y'all probably know what metallic bonds are. I don't. If you do, explain it to me, please. Anyways, two nonmetals form covalent bonds, and one metal plus a nonmetal form an ionic bond. If you remember in the last video, an example of this was sodium and chloride. It turns out sodium is a metal. I had no idea until I looked it up. And chlorine is obviously not a metal. It goes into pools. That'd be kind of weird to have metal. But anyways, those are just general rules of thumb. So let's continue. Please remember these rules are kind of important. On to the back. So this is a lot of writing, I know. Ionic is taking one or two electrons to have a full valence. Remember, this happens when there's a really big difference in electronegativity, plus the rules. And covalent bonding is basically just sharing. Sharing is caring, you know? Which is good. We love sharing around here because when you share, people are happy, and we need happy people. Anyways, so why is it covalent and not ionic? This is more me specific. I had this question. I was so confused. I was like, wait, because some covalent bonds, the electronegativity difference is pretty high. So why aren't they ionic bonds? Basically, it all has to do with electronegativity, and the rules help as well. So in the case of, and I'm going to come back to this later, hydrogen and oxygen, the electronegativity is pretty great between the two, but they don't ionic bond because one, I found out that the difference has to be above like 1.8 to 2 in the electronegativity, and two, hydrogen and oxygen aren't metals. So two nonmetals, remember, form covalent bonds. Those rules come in handy. See, it's kind of important. Anyways, so just keep this in mind. Something with a giant difference in electronegativity, and it's a metal and a nonmetal, probably ionic bonding. And two nonmetals with not much difference in electronegativity, probably covalent. And so let's talk about the different types of covalent bonding. So, this is what is known as a non-polar covalent bond. It's when the elements, yes, it's when the elements share the electrons equally. So as you can see, he's like, here, have some electrons, and the other guy's like, thanks, here, have some of my electrons. This is good. We need more of this in the world. Not sharing of electrons. We don't, I mean, well, we do. That's how things like exist. But like, we don't need to, you know what I mean? We don't need to share electrons. I mean sharing in general. Anyways, but we do live on Earth, and people are greedy. Look, it's the Monopoly guy. I had fun drawing him. And since people are greedy, elements are no exception to this rule. Looking at you, oxygen. Oxygen, as you are about to see, is a pretty greedy fellow. Hello. Hello. And so, like I was saying, oxygen is a pretty greedy fellow. When oxygen is covalent bonding with hydrogen or any other nonmetal element, unless the electronegativities are similar. So like, this is just off the top of my head, oxygen and carbon are like almost right next to each other, I think. So the relationship between them wouldn't be like this. But between like oxygen, like something with, how do I explain this? Something that has a lower electronegativity and something with a higher one. This is how the relationship typically goes. Basically, oxygen has a higher electronegativity, so electrons are around oxygen more than they are around hydrogen. It basically takes up all the electrons. It doesn't take all of them like in ionic bonding. They're still being shared, it's just an unequal amount of sharing. This is polar covalent bonding. And because the oxygen has like so many swarms of electrons around it, this gives it a partial negative charge. And hydrogen, because it doesn't have as many electrons around it, it has a partially positive charge. And as you can see, 2 hydrogens, 1 oxygen, that makes water. Water, yeah, the thing that we drink sometimes. And the reason water has this bent structure to it is because of the 2 partially positive hydrogens at the bottom. As you remember, positive, positive, negative, negative, they repel each other. So these guys are kind of moving away from each other because they don't like each other. Why? I don't know. Anyways, water. Water's yummy. Water's good. Drink water. Oops, I mixed up the signs. That's supposed to be a check mark. That's supposed to be X. Or is it? I'm kidding. You should drink water. It's healthy. But also you could drink whatever you want. I'm not telling you how to live your life. Do what you want, man. As long as you're not hurting anyone, please don't do that. That's not okay. So, anyways, back to this. So, you might be wondering, because you're a curious person, wait a minute. If these guys have partially negative and partially positive charges on them, and positive and negative like attract each other, could these guys bond too? No, they can't. That was a stupid question. I'm kidding. They can. That's, if you really thought of that, you're like pretty insightful, because I didn't think of it. I was reading and then I just read it and I was like, oh my goodness, I didn't even think of. That's my sibling. Ignore him. Anyways, I was like, I didn't even think of that. That's so crazy. But so if you thought of that like before, I revealed it, then dude, you're on track to becoming another Einstein. I'm gonna end up working at McDonald's. Anyways, yeah, so they can bond, and that's what I'm gonna talk about in the next video. Because these specific, well, okay, for one, polar covalent bonding is a type of bonding, obviously. And these molecules that they form, they can bond to other polar covalent bonds. These ones specifically, they're called hydrogen bonds because of the hydrogens on the end, and that's how we get water, ice, gas, and yeah, pretty much that stuff. And it's really fun. It's like my favorite thing to talk about. So I'm gonna talk about that in the next video, which will be really soon because, again, I love it. So yeah, I'm excited to talk about hydrogen bonding. Anyways, have a great rest of your day/night, and I'm glad you watched the video. And yeah, have a great rest of your day. Night. Bye.